Hello everyone, this side Ritika, and today we are going to talk about modulus of elasticity. So here we have three types of modulus of elasticity. Number one is Young modulus, two is Shear modulus, and three is bulk modulus. Young modulus is a mechanical property that measures the stiffness of a solid material. So what is stiffness? Stiffness tells about how strong the material is and how much load it could bear without any failure. So Young modulus has come from Hooke's law. About Hooke's law we have studied in our previous video also, that was of stress strain curve. So according to Hooke's law, when a material is loaded with an elastic limit, the stress is directly proportional to strain. So when we remove the sign of proportionality, there is a parameter E which comes after removing this sign. So this E is your Young modulus of elasticity, which tells the stiffness of a solid. Now bulk modulus. What is bulk modulus? It is simply the measure of the decrease in volume with the increase in pressure, right? Let us consider a water droplet. What we do is we apply a pressure P on it. After applying a pressure P, volume of water droplets becomes V dash from V. So what we observe, that volume of the droplet is reduced. Therefore, bulk modulus will be delta P upon volumetric strain, where volumetric strain is delta V upon V, that is change in volume upon actual volume. And why this delta P is considered? See, earlier there was a atmospheric pressure. So here we take the value of change, that is what was the change in pressure. So after applying P, and earlier there was atmospheric pressure, so considering these both pressure, we take the value of change in pressure. So this is what called bulk modulus. Now come to shear modulus. Shear modulus is represented by G. So it is the ratio of shearing stress to the corresponding shearing strain. Another name for shear stress is the modulus of rigidity, and its SI unit is Newton per meter square or Pascal. SI unit is same for each modulus. For both Young modulus and bulk modulus, unit will be same, that is Newton per meter square. Now let us consider an object. Here a force F is applied which is parallel to the object. This is the main point. In our earlier modulus, the force was perpendicular. You can see here the force is perpendicular. In Young modulus also the force was perpendicular, but in case of shear modulus, this force is tangential or parallel to the object. So when force is applied, there is change of delta x. There is change in position, and the position change will be at delta x and at an angle of theta. Here consider the base will remain on the same position, only displacement at top surface will take place, right? The base is at the same position. So mathematically, shear stress is F upon A, where F is tangential force, A is area of cross section where the force is applied, delta X is displacement from original position to the new position, and theta is the angle at which displacement takes place. So mathematically, shear stress is force upon area and shear strain will be tangent theta, where tangent theta is perpendicular upon base. Here perpendicular is your delta x and base is L, that is length of the object. So tangent theta equals to opposite upon adjacent, where opposite is your delta x and adjacent length is L. So this is what called shear modulus. Come to Poisson's ratio. Poisson's ratio describes the expansion or contraction of a material in direction perpendicular to the direction of loading. Mathematically, it is lateral strain upon longitudinal strain, represented by mu. Now, see this object. Here, the force F is applied in the longitudinal direction. You can see here tensile force is applied. Because of this force, there is contraction in this lateral direction. So there will be change in longitudinal direction and change in lateral direction. So we can see there will be expansion in the longitudinal direction and there will be contraction in the lateral direction. You can take the example of rubber. When we stretch a rubber, it expands in the longitudinal direction and it contracts at the lateral direction. Thickness is reduced. So because of that, Poisson's ratio is calculated. So Poisson's ratio will be lateral strain upon longitudinal strain. Now relation between G, E, K and mu, where G is modulus of rigidity, E is Young modulus, K is bulk modulus and mu is Poisson's ratio. The first relation is 9 upon Young modulus equals to 1 upon bulk modulus plus 1 upon modulus of rigidity. This is your first equation. Second is your nu equals to 3 into bulk modulus minus 2 into modulus of rigidity upon 2 into bracket 3 into bulk modulus plus modulus of rigidity. See, these equations are very important. They are directly asked in the exams. Numericals on the basis of these equations are asked. For example, if we consider this first equation, you will be given bulk modulus, modulus of rigidity. So by these two modulus you have to find Young modulus. So if you remember this equation, you can easily find the value of Young modulus. In the same way, these two equations are there. Third one is your bulk modulus equals to Young modulus upon 3 into 1 minus 2 into Poisson's ratio. And the fourth one is modulus of rigidity equals to E upon 2 into 1 plus Poisson's ratio. For example, if we consider this equation, you will be given Young modulus, you will be given Poisson's ratio. By the help of these two values, modulus of rigidity will be asked. So you can easily find the value of G. So you can see how helpful these modulus are for you in your competitive exams, in your university exams. It could come anywhere. That's all for today. I hope this video is helpful for you. If you like this, give a big thumbs up. Thank you.